So yes, good evening. My name's Chris Horsley, and so I came and did a talk last year, and I currently worked Viagra into the title to make it a bit salacious, and it was all about how to defend a website. And the feedback I got at the end of that talk is, what you commonly get from security talks is that it harshes everyone's mellows a bit. It's a little bit of down. So this year, what I've done is, I'm talking about a topic that's a bit more constructive. Security is a very destructive sort of discipline. So tonight what I'm going to talk about is something else I'm very passionate about, which is data visualization. So I'm going to talk a little bit about at least what I mean by data visualization. You hear it used, lots of different terms used. So sometimes you hear information visualization, data visualization, infoviz, visualization. For the purpose of this talk, they're all just equivalent. I'm going to talk a little bit about why we visualize data, then what a good visualization sets out to do and how to construct a good visualization. Then I'm going to talk about the different tool sets we have available to us to build visualizations. And I'm going to talk about one in depth called D3 that I use myself and I'm a big fan of. There should be something in here for any level, whether you've come along because you didn't know much about data visualization. I think there'll be something there. If you've been interested in data visualization, there'll be some good concrete steps to take you on the next step of that journey. And if you've been doing data visualization, I hope there'll be some new techniques, maybe some new types of visualization, some new tools that you can take away and start using at the end of tonight. So to give a bit of my background, I think it's always good to get the biases of the speaker in mind. So I started my professional life in the late 90s as an application developer, mainly for web systems. And while I was developing these web applications, I got very interested in information security. And I moved full-time into doing a security role. And it ended up being a very fortuitous little combination of two things, because data visualization, in many ways, it's chiefly an application development problem. And in information security, one of the biggest problems we have is parsing massive amounts of data and looking for that one event in a big log file which tells us that an attack is happening or there's something weird going on. So data visualization ends up being a very handy tool, and being able to develop particularly web applications or any applications lets us delve into that data and learn more about what's happening with the security of our systems. So visualization is a pretty broad term. So let's try to narrow it down a little bit. The way I like to describe it is it's making data for human consumption. So we sit on absolute massive piles of data. Even on this MacBook here, which is connected to not much, there are SSH logs, there are web server logs, there's mail accounts, there's all sorts of stuff there. And it's all chiefly designed for computers. They're designed in a very reliable way to parse. But if we look at a data file like this, an SSH log file from my system, it's great for being reliably able to sort of process it, but it doesn't knock me over the head and show me the trends. It doesn't show me how many people connected today. It doesn't show me which of these events looked a bit suspicious. There's something missing here that we need, and quite often that's the data visualization part of it. So it's turning a piece of data into a story, and one of the best examples in recent history for me was this data visualization by Al Gore in An Inconvenient Truth. And if you've seen that movie, you probably remember this scene. They even featured it in The Simpsons because it was so engaging. And it's nothing more than a line graph. So I guess that shows the first rule of data visualization, in that it can sound like a bit of a foreboding term, but what it's really about is drawing pictures about data. And a line graph is something we all learn to do in grade 3. And Al Gore is using that technique, and he's given it a really nice twist by using this cherry picker to show the amount of CO2 emissions into the atmosphere. In that vein, visualizations can be very simple. A simple bar graph like this, it tells a story about a data set very simply. And the reason we learn about this in primary school is because it's a really effective technique. I'm going to show you some pretty sophisticated visualizations later on that are possible, but I think it's always worth remembering that these basic skills, they don't have to be graphical at all. they could be completely based on ASCII text. In fact, there's a plugin to build sparklines on a command line. If you're not familiar, a sparkline is a really compressed bar or a line graph. So you can use your command line and you can pipe data from a file, and on your command line you can build yourself a little visualization. So it doesn't even have to really be graphical in the way we understand GUI graphical. You can also have a visualization that is quite sophisticated. So this example is called a stream graph, and it comes from the New York Times. The New York Times are really worth checking out. They have this, this group, I think they're called the Media Lab or something like that. And they build a lot of these very sort of experimental visualizations. So this visualization shows box office returns over the course of a year. And the peaks and the troughs, it's not about losses, this is more about just to remove some of the clutter by putting things above and below the axis, but the height shows you the box office take. And then the length of each of these, so up the top there, the tallest peak you can see, that's National Treasure, that Nicolas Cage movie. But we can also see, well, how long did the box office returns last for? Was it a movie that maybe started with a lot of hype and then everyone said it was rubbish and it fell off very quickly? Or was it a movie that didn't have much marketing, but it was a sleeper hit and everybody got to know about it, so maybe it had a slow start, but then it started to really rocket up? And this is also an interactive visualization if you to look at it on the internet. And so we can isolate particular movies. So this tells a really nice story about what were the highest grossing movies of the year, relatively speaking, when did the movies come out compared to one another, how long did each movie run for. There's a lot of data packed into this one visualization. So the reason I love data visualization is that it's this lovely combination of left brain and right brain thinking. It takes a lot of the skills of analysis. So in the security discipline, we do a lot of work with data analysis particularly. As I mentioned before, things like log files and data parsing. So we have that analytical side that we want to achieve an outcome where we understand a problem set better. But what we're really designing these visualizations for is humans. And humans, we're logical sometimes, but we have all of these biases in our brains about the way we look at information. I mean, some of the classics are, we pay very close attention to patterns. So things like if something's bigger than something else, we notice that. If something's different color to something else, we notice that. And these are techniques we can use in visualizations to make our data points, the interesting data points, stand out from the crowd. So there's a lot of psychology that goes into building visualization and understanding how people think and how people see as well. So it's a good workout for both sides of the brain. So I've often thought that visualization is a lot like photography and taking a photo. And I love photography as well, actually, so maybe that's why there's that parallel there. They say that with a photograph, or with a painting, a good painting is born because of the detail you put into it. But a good photograph is born because of the things you cut out of the image. It's how simplistic the image is and all the clutter you manage to eliminate. And a good photo ultimately tells a story about a particular moment in time. And a visualization, a good visualization, should do the same thing. So here's a few examples of what we might get out of a visualization. So firstly, we use visualizations to tell a story. Now, this is a simple line graph once again, and it tells the story of the Japanese real estate market. Now, if you haven't heard of it before, and after the GFC, I'm sure you might have, in Japan during the 80s, they have this massive property bubble. And that's where we're looking at this peak going up here. And then right around 1992, 93, the bubble collapsed. And they reckoned at the height of this bubble that the Imperial Palace in Tokyo was worth more than all the real estate in California. That's how bubbly it got. And it flatlined and it went down and down, and even 20 years after that bubble popped, the Japanese real estate market is still in decline, even with real interest rates close to zero. So this is a really simple visualization, but it tells a really strong story about what happened in Japan with their real estate. This is a more sophisticated visualization. Now, this is more of an analysis tool, and if you haven't seen one of these before, it's called a tree graph. So by way of explanation, this is something that maybe a stock analyst might use. So each of the small squares that you can see here, these represent individual companies. Now, the size of each of those squares is the market capitalization. Okay, so now you also see if I've got a mouse cursor somewhere here. No, I've lost the mouse. Each of these small squares is clustered into a bigger group. So you see up the top we've got energy and finance and healthcare. So they're divided up into sectors. And then finally we've got each of those squares is a certain colour. It's red or it's green, which indicates if the stock has been going up or down. And then really bright green squares, that's a strong uptick in share price. And then a strong red colour, that's a sharp drop in share price. So this tells us a lot of things. So firstly, we can look at it as the health of the whole stock market. On the whole, it's looking sort of greenish. So there's that to start with. Then we can look at individual sectors. We can look at energy. And energy is definitely looking very red there. So we can work out that energy as a sector is in decline over whatever period of time this visualization is for. And we can look at healthcare and we can go, oh, okay, well, healthcare is actually increasing. Now, the nice thing about this visualization, if you look at it online, it's actually kind of famous because it was one of the first tree maps that got a lot of traction, and it showed people what tree maps could do. It's interactive as well. So if you put your mouse over any of these squares, and you can see this label, this VFC Corporation down here, if you put your mouse over that, it gives you the detail. So for me as an analyst, I can look at the overall health of the market, but I can also find any point of a particular company and I can find out the details. So in other words, this is the launching point for me to find those points of data that are worthy of my attention. And in lots of cases, that's why visualizations are so useful. It's about taking some massive set of data and highlighting to me as an analyst, where are those next points that I should be looking at? What's exciting? What's changing? What's trending way outside what we expect? And that's what this sort of visualization can do. Different types of visualizations are about, I guess, reorganizing data to give us new understandings. So this is, well, the lines don't come through. These are actually connected by lines, and they're showing us the relationships between the libraries of a visualization library. So we can see how many top-level libraries are there. We can see how many layers deep is it. We can see which libraries have the most, say, sub-libraries present, so we get a new understanding of that library from presenting it in a different layout. I think another good hallmark of a good visualization is to be attractive. Now, when we say attractive, that's a pretty vague word. So what I mean by that is, particularly in the security area, I see a lot of visualizations and they look like they were just, they're done using pretty basic tools. They spit out PNGs, but there's no, say, anti-aliasing. They've got those jagged edges to all the circles. And I'm sure if there's designers here, you probably think that's pretty abhorrent to not use, say, anti-aliasing, but I see it quite a lot. And even though I know that the data that's gone into this visualization that looks a bit shoddy is probably good, we have that saying, don't judge a book by its cover. And we have that saying, it's because it's what we all do naturally. So if we don't make that data look at least look professional, people make the assumption that the data that's underlying it is also weak. But now the good news is, even if you're a bit design challenged like I am, there's lots of toolkits which just automatically make things look good. So it's just a matter of picking the right library that does that for you. And I'm going to talk about some of those good libraries a bit later on. So another thing about, or another feature of good visualizations. So if you cast your mind back to high school, when you were doing maybe journalism, remember you were writing those mock articles for newspapers and things, and the idea they would hammer into your head over and over again was, think about your audience. Think about what your audience is going to take away from this article. And with visualization, that's very much the same mindset we need to have. You see a lot of visualizations, and you can kind of tell that somebody's just taking some data and they've just done a bit of work on it. They've thrown it into an algorithm and they said, hey, I made a visualization. You see it very often with mapping-based visualizations. We just take some points and throw it onto a map. But if we were to look at that map, it doesn't really show us a trend. It doesn't give us a point to go and look at next, like that tree map where we had the next company to go and research. It doesn't give us an overall trend about the data. So as we're building the visualization, we very much need to keep in our minds, after somebody has viewed this, are they going to learn something, or are they going to be able to do something after they've had a look at what we've built? So over the time I've been doing data visualization, I've come to this theory that there's two major types of data visualizations. And the first one are what I call insightful visualizations, or sometimes operational visualizations. And these are things we use every day to actually get things done. So in the security world, for instance, we have visualizations which show us, say, attacks that are things we haven't seen before. So those are the things we want to flag, and we'll look at that on the screen and we'll go, yes, that's something I need to look at, and I'll go away and take some action based on it. Now there's another level of visualization, and we can politely call them high-level visualizations, but they're very often referred to as management porn. And I mean, that's a bit prerogative to talk about it like that, or pejorative to talk about it like that, but these sorts of visualizations, I used to be a bit down on them, that they were worthless. But I've now changed my thinking that they're actually not. Because, so I built a lot of visualizations over time, and often you bring in, the VIPs. So I used to work for this organization in Japan, and we were funded by the government. And we'd very often get these VIPs, and almost 100% of our funding came from them. And when you're providing 100% of the funding, you get afforded a fair amount of respect. So they would come around our office and poke at things and do all the rest of it. And we'd show them our operational visualizations, which we used every day and we loved. But they would just have a so-so reaction to it. Then a few years later, we built this system to monitor attacks all through the Asia-Pacific region. And somebody built a visualization on a map. And this map, what it showed was, every time that we noticed an attack happening, so say it was going from Thailand to Korea or Japan to Australia, the map would do an animation to show this line that would arc across the Earth, like a DEFCON map, like a nuclear war map. And it would show this packet, it could be a ping, going across the map and landing in this other country. So you could imagine for tens of thousands of packets a day, there was this map, and it was just going crazy with all these lines crisscrossing it. And it didn't tell you anything. You couldn't look at this map and understand anything about new attacks or what it did. But when we brought the VIPs in and they looked at this map on a big LCD running on the wall with crazy stuff happening, they loved it. And they thought it made us look like we knew what we were doing, even though we never touched it on a day-to-day basis. And one of my colleagues did a TV interview, and we had this visualization on the wall behind him. And I got to say, it looked really good. He was standing in front of this map. It looked like he was standing in some sort of sophisticated ops center. He was really standing in our little meeting room. So there is a role for these sort of visualizations as well that maybe don't tell a story, but they have an impact. But for the purposes of this evening, I'm mainly going to talk about these operational day-to-day visualizations, but a lot of the techniques work in both. This is the sort of visualization I mean, that's sort of a management porny sort of interface. This is a plugin for Chrome. Well, not for Chrome, but for WebKit browser, I think. It shows a globe and you can spin it around. And I'm not sort of slagging off this particular visualization, but the data that went into this particular visualization, it doesn't really mean anything. Just looking at it, it doesn't really tell us any stories about the data. So let's talk about the sort of visualizations we are going to focus on today. Now, we're going to try to pick a tool that's good for doing data visualization. So before we pick that tool, we need to come up with some criteria for how we're going to pick it. So here are 4 criteria that I think are good for these sort of operational visualizations. And it's different for the sort of visualization, of course, that you're doing. There are many stories, and this one's mine. So the first one is that a visualization should be reusable. And what I mean by that is, if we get a new data set, we should be able to plug it into our visualization and we can generate a reliable new graphic to show that data set. So I don't want to build a visualization and then have to keep tweaking the tool every time the data changes. I'm lazy. I want to run this thing over and over again and get a result. The second thing, in a similar vein, is that the tool should be automated. I've learned through bitter experience that if you have to do anything manual to update a visualization, people will get bored of it after about 3 days, and then your visualization gets a bit dusty in the corner. It's got to be fully automated. Either you schedule it, to regenerate the visualization, or you do some clever, real-time streaming data or something like that. So it has to be automated. The next thing when we're picking our toolkit is that it's got to be interactive. So that tree map I showed you, a lot of the power of that tree map comes from me being able to filter and pick a company and get a little pop-up that shows me the stock code, the amount of increase, the share price, and all that other good stuff. So interactivity is definitely something we want in our visualization toolkit. And finally, we want it to at least be capable of animation. Animation can get, it can be abused, but there's many visualizations, I'm going to show you some tonight, where animation really enhances the understanding, especially showing transitions for how we got from this set of data, from this state into this state. If we just drop from one to the other, it's a very jarring experience. But if we can animate from one to the other, it shows us how the data moved and how it progressed. So I'll talk a little bit about what sort of visualizations that rules out then with these 4 criteria. So the first one it rules out is infographics. Now if you're not familiar with infographics, if you've never been to Reddit in your life, because you'll see a lot of them there, an infographic is basically a bar chart with clip art to sort of lay in the boot to it a little bit, which is what this one is here. You take sort of what somebody considers a bland graph or a bland statistic, and you use some really nice design techniques. Like this one's a bit ugly. I picked it on purpose. There are nicer ones, but they might use some alternating fonts to tell a story, or maybe a really creative layout to show a progression. Now the reason we rule this out is I want to generate these visualizations all the time, and anything which requires me to touch Illustrator or Photoshop or any manual effort, I'm just going to rule that straight out, because that requires work for me and I'm against that. The second thing is, well, after one-off visualizations, static images. So I see a lot of visualization tools which are, they're designed to output, say, PNG files or GIF files. And that used to be fine, but we've got much better tools now. I mean, we already failed the tests of interactivity. I mean, we can get some basic interactivity from an image if we marry it with an image map or something like that. They've got very primitive animation built in. So static images, I think we can do a lot better than visualizing data with static images. Flash. Now Flash, I'll rule out just because of device support. If we want to get our visualization on as many platforms as possible, these days Flash is becoming more difficult to run on different platforms, so we'll rule that one out as well. Desktop tools, there are some really sophisticated visualization desktop tools, and usually the power of those is they let you tweak the data and filter the data and play with the data very heavily before we output something. And they've definitely got their place, but we're talking about doing automated visualization that runs based on algorithms and without our input. So we're going to rule that one out of our toolkit candidate list as well. And while we're on the subject of what we don't do with visualizations, this is an important word to know in the visualization world, and it's chart junk. And it was invented by this guy, or coined by this guy called Edward Tufte. And he's seen as a bit of a guru in the visualization field. You might have heard of him. But basically what chart junk is, it's any pixel or any amount of ink on a visualization which doesn't somehow add immediately to the story that we're trying to tell. So the classic example would be 3D. Very often 3D doesn't add, it's just trying to look a bit more sophisticated. The other ones are things like unnecessary gradients or patterns or clip art in the background, or putting a background on your graph, let's say. So in the world of chart junk at least, that these things are seen as being bad. I mean, of course this is a very subjective measure in terms of having a nice design versus having a very stark looking graph, but I think it's a valuable mindset in that we're trying to tell this story and we should try to do it as directly as we can, much like a piece of good writing. Good writing often tells a story with less words rather than more, and we should be aiming to do that same thing with our visualizations very often. So based on our reusability, automation, interactivity and animation, what's a good toolkit then? And I'm seriously not pandering to the audience, but HTML, HTML5, JavaScript are an excellent solution to doing data visualization. So why would you use web technologies? Well, firstly, using something like some of these JavaScript toolkits that are out now, they're driven by algorithms. We pipe data into it, it applies an algorithm about how to lay out the data, and it gives us a beautiful looking visualization. They're automated because we can either generate them on a schedule because it's all basically text, So we could either statically generate it, or we can use something sophisticated like WebSockets, and we can pipe our data in there real time instead and get it to do animations as it updates. It's interactive. It's interactive at the basic level of hyperlinks. That's a level of interactivity that we get for free in web browsers. But also we have things like SVG and some of the extra things that it provides. We also have animation, one's against your SVG, but we can also just animate the standard elements in the DOM. We can animate divs, we can change the size of divs. So even though a lot of the visualizations I'll show you tonight are SVG, you can do a visualization using plain vanilla HTML as well. So a few other advantages. Firstly, there's a lot of work going on in the visualization space for web browsers and using JavaScript libraries. So you can save yourself a lot of effort by going and getting all of these tools, which are also free as an added benefit. The other nice thing is a lot of visualization tools I used to use, maybe command line tools, specialized visualization tools, often relied on custom data formats. So you would have to take your data and then write a custom parser in Perl or Python or something and sort of massage it into the right format to pass into the visualization tool. But most of the web-based visualization toolkits, they all use JSON as their default state, and you can take that same formatted data set and pipe it into this tool or that tool or the other tool, and they're all basically going to read the same stuff. And of course, the biggest benefit we get is that it's very nicely cross-platform, which is a benefit of web-based applications anyhow. All right then, so let's look at the more concrete side of how we would get started building our web visualization. So I'm going to show you a few toolkits. There's a lot of work going on in this space. I'm going to just talk about three that I have a passing knowledge of. So the first one is Processing.js. And this is born from a Java library called Processing. And processing isn't strictly a visualization framework. It was actually designed more for artists. So maybe artists who weren't strong programmers, but they wanted to make electronic art of a sort. And data visualization really is an offshoot of electronic art in a way. So Processing.js is the JavaScript port of that. Now, because it's very flexible, it's a very flexible tool, but that also means you have to manage a lot of things by yourself. So you have to draw, you have to manage drawing circles and drawing lines and squares, and you have to do all that work by yourself. But as a plus, you get a lot of flexibility. So maybe if there was a visualization that wasn't catered for by something else that was out there, maybe you would have a look at Processing.js to get a bit more raw control over what it was you wanted to output. And I used Processing.js back in the day, and it's really good, but I guess I found better things a bit later on. So this one, JIT, it's a JavaScript Impervious Toolkit. I've not used this much, but I've been following the development pretty closely, and it looks pretty good. It's got all these layouts, things like that tree map we saw. So you just say, I want to make a tree map, here's my data, and it builds you a tree map. And then you can build customization on top of that. And it comes with a whole gallery of stock visualization types, things like line graphs and bar graphs and all that standard stuff that you would expect. Like I said, I haven't done a lot of work with it, but I would recommend, if you're interested, going and having a look and see if it fits the way you think perhaps. Now the one I'm going to talk about the most is this one, D3. Now this is developed by a guy called Mike Bostock, who's a very clever fellow who's developed a range of hugely popular JavaScript libraries. And he developed a library called Protoviz that I started using a few years ago. And I started to hit the limits of it, and I guess Mike had thought the same thing, and he built D3, which kind of built that whole thing from the ground up. Now the thing that's really revolutionary, I think, about D3, it's the way it thinks about data. So if you can imagine we've got this big data set, and we've got some stats in it, and imagine we're building a visualization. Let's imagine we're going to paint some circles on the screen, depending on what's in our data set, right? So the first thing we think about is, okay, well, let's loop over the data, and for every single data point, I want you to draw a circle. Now, if you see this sort of a circle, I want you to set the radius to this before you draw it, and I want you to set the color to that, and you end up with all these if statements to set color and the radius and the stroke width and all of these things, and it ends up being a bit of a mess. So what D3 does is it just already assumes you're already working on a data set. So you give D3 a data set, and then essentially what you do is you say, here are some rules for how to handle that data. and it kind of subsumes your data set and just follows those rules you set out. The very clever thing it does as well is that if I change that data set, it knows how to reapply those rules, but also transition from one set of data to the next. So the brilliant thing it does is making a visualization which has graphical transitions. So if you had a circle on the screen at 10 pixels across, and then suddenly that point became 100, rather than just jumping to 100, you can just say to D3, just animate that, and it will do a nice, a nice thing with an ease in and all the rest of it, and it will show how to animate it, and it's one line of code to essentially turn on animations as the data changes. So you get all that for free. And D3 has become very popular of late for people who are building, you'll see them on New York Times, and you'll see it in a bunch of places, people doing D3-based visualizations. So, how would we go about building one of these visualizations ourselves? So the ones I showed you, these are all pre-packaged. Somebody has built them, and they're either available as a D3 plugin or a D3 native visualization, and there's stacks of visualizations built into D3. There's maps built into D3. The author also built a mapping library as well, so you can build some really nice map visualizations. It's got tree maps, it's got graphs, it's got bar graphs, and it does them all very well. But what if you wanted to build a whole new visualization completely from scratch? So this is something I attempted earlier in the year, and I built quite a visualization using it. I put a lot of time into it. So what we're going to be doing as a very simple example is building this visualization, 3 dots based on a data set. Now the amount of code we need, so firstly there's some HTML. The main points are we import the D3 library, of course, and then we have a div which is going to serve as our SVG canvas. And then we have this JavaScript, which is like special D3 JavaScript. So we start from that top line with the data set, 3 elements for our 3 dots. And this is basically all the code we need to draw those 3 dots. And if we were to update that data set, we could have that visualization dynamically update and move around on screen to reflect the change in the data. So it's not a lot of code to really get started building a D3 visualization. There's some new ideas in there, which I know for me it took new ways of thinking about how a library should work. But once you're over those little hurdles, it's really lovely to use, and you can write visualizations in a fairly succinct way. All right, so that about wraps it up from me this evening. So just in summary, so what I think I would like to really impart is that the idea of data visualization, it can be to make things look pretty, but often it's to tell stories about data sets. And we've got so many data sets that are orphaned and sitting unloved on servers somewhere, and they need to be brought out and brought to our attention so we can see those interesting things that exist inside that data. And data visualization is a really powerful tool for doing that. And then we looked a little bit at different toolkits, and so using HTML and JavaScript and web technologies is a great way to do visualization. Now I should add as well, it's not the only way to do visualization. I've seen some visualization toolkits that deal with gigabytes of data, and they use the GPU to do processing, and those are things that are still beyond the capability of web browsers at this point. Web browsers still have problems if you've got enormous data sets. They still have problems. We're still in the prehistoric period of 3D in the browser, but as you know, browser tech is getting better all the time, so I'm confident that that's going to get better over time. But I would say for 95% of most visualizations, the browser is an excellent platform to choose. And I would highly recommend looking at D3 if you want to get started doing this sort of visualization. You get so much for free, and very often you can build this visualization really without having a complete understanding of how D3 works. But you can get to that goal and gradually build up your knowledge as you want to tweak it more and more. So that's about it from me. Thank you very much, and if there are any questions, please feel free. Thank you.